Next part which I'm talking about, like this is the practical application. What it is here, this like graph you will see everywhere on internet. Here what is saying, like when like center of the target is a model that perfectly predicts the correct value. So here when you're when this kind of bullseye here on a dart game, this is a bullseye. Like if you have all the prediction here, then it shows like you have low bias and low variance. If like your this prediction starts varying, then and still it is like around this bullseye, so I am saying it has low bias but it has high variance. All right. So in this case, if like this graph you don't have to create, I will tell you, like we have two lectures for this. Like first is Bias-Variance Tradeoff, then we'll see the regularization part also. So in that also it show you like how to reduce this and how to take care of bias and variance. All right. And here you can see like we have low variance because all these data is present like around it, but it is far from this bullseye. That is why I'm saying, okay, this is high bias, and it is like far from a bullseye, but it is also spreaded. That's why it is high bias and high variance. This is the meaning of this graph. Okay. So what we do here, we reiterate our model until we get our values like this. When we reach here or closer to this, like it closer to this, when we reach, then we say, okay, this is our model which will work on my train data as well as on my test data. Okay. So this is what I was talking about. When I have like this all lines I'm going through, then it has high variance, and we call this as a overfitting. That's my model is now overfitting, right? Overfitting, what it means, like my whatever model algorithm I have created, that is learning all the things, all the signals from my train data, and because of that, is it like overfitting on that? Like it is taking that number or that value as like as like constant. Okay, that value or train data, that is whatever it will predict, it will based on that train data only, and it will more and more predict the same thing. Like when you this on this line, if you have test data here or here or here somewhere, so for this x it will always predict this value because it has totally like learned the signals from a train data. So that's why it is not predicting good on your test data. That is, it is high variance. High bias, like if it is a simple model like this, a line you are creating, so in this, like it is underfitting because it's not taking all the signals from that, because bias is all about taking the signals from your train data. And when you have low bias and low variance, so this will be kind of like this graph where you have a square, and it is like you are not touching all the points here, but you are touching maximum of them. And all, if you have a test data like this, so it will give you minimum error in this case because it is a good balance of it, right? So like how do we know it? Like when you have a train data set, and when you create a model and you see you have a high training error, then you see your like if you have a high training error, like train data only if you are predicting and it is showing you high training error, that means like your model is not taking all the signals and it is like underfitting on that, right? And here in this case, if it is not learning all the signals, then your validation error and test error will also be the same high as a training error, because your model is very simple, that is not able to catch all the information from your train data. In a layman term, we can say that like it is not catching all the information from your data, right? Overfitting, like you are learning all the signals. So what will happen? You have low training error, but you have high validation or error or high test error. So you have to go in between somewhere and you have to find the good balance.